And I'm really happy to be here, and I'm happy to present this second part of the Alice adventures in the world of Kubernetes. And this time, Alice will learn how to use Kubernetes from Scala. So I'm Roksolana, and as it was said, I work as big data developer at Captify. Captify is the largest independent holder of user search data outside of Google, and it's based in London, but also there is an engineering team in Kiev where I'm based. Also, I'm diversity inclusion ambassador there, Women Who Code Kiev data engineering lead, mentor, and I often speak at conferences and meetups. So a small disclaimer is that there's going to be a lot of examples, but I'm not going to show like the whole project setup because it would just take too much space and on the slides, and it's more convenient to see like the most important parts of the code, which would convey enough meaning to understand these examples and just in general the idea. And another one is that most examples will be using one library, but I will show a bit from other libraries that can be used for the same purposes. So you would be able to research it further if you would need to. So as I said, it's a second part of the Alice adventure story. So I'm going to make like short recap, just to understand where Alice is right now in terms of her adventures and her knowledge. So in previous story, Alice visited her uncle, and mysteriously she got into this world of Kubernetes and functional programming. And her first stop was functional forest, where she learned about the functions, the functors, monads, and she met the pods there from the Kubernetes part of the world. And also she visited the default namespace city, which is a Kubernetes part of the world. And she learned that the buildings there looked like constructor details, and they kind of constituted the type system. And eventually, she kind of built up these similarities between these two parts of the world. Specifically, that in functional programming, there is a type system. We work a lot with types and the hierarchies, while in Kubernetes, it can be defined using the Kubernetes API for objects. So we might have like a pod, and it's embedded into replica set, which in its turn is lower in terms of hierarchy to the deployment. So there are kind of type systems there as well. Another aspect is immutability, which works great for functional programming because we operate a lot with immutable data. While in Kubernetes, it doesn't always work that way with all the immutable objects, but in most of the cases, when we want to change something drastic, like the name of the object or the number of replicas, like instances in terms of Kubernetes, we would have to recreate it. So in most of the cases, we can consider Kubernetes objects immutable. And another aspect is declarative nature. In functional programming, we can imagine that we wouldn't have to write each instruction to the machine, like to actually perform some counting even. We would operate already on the higher level using programming languages and thinking what we want to achieve with that. And we wouldn't think like what exactly happens inside of the computer and all of that. While in Kubernetes, declarative nature works in such a way that we define description of the objects we want to have in YAML files, and we don't care how they are created or updated. Kubernetes does it for us. And another interesting aspect is DSL, or domain-specific language, which means that in functional programming, it can be a programming language or framework specifics, while in Kubernetes, it can be represented using YAML files because it's kind of a language in itself. We have to learn the signatures, the names of all of the specifications and everything. So it's kind of DSL. And learning that, Alice learned how to create multiple Kubernetes objects as well, like pods, deployments. And she created this magic database using persistent volume, which looked like a safe lock to the right side of her here. And the MagicDB cluster pod here is like an instance, one of the instances of this magic database. And this magic database held her knowledge about this world. So Alice didn't really want to leave it there, and she decided to take this database with her, and in such a way she escaped back to her world, and the pod just tagged along with her. And now we skip to 2 years later. Over this time, Alice learned Scala, became a successful Scala developer working in a big city, and at some point she decided to take a vacation because it's been some time since she visited her uncle, like her previous adventure 2 years ago. So she decided to take a break, and she didn't really expect anything from that vacation. She just was relaxing, having a great time. And then one of the days, she decided to have a walk in the forest, which wasn't scary in some way for her. Kind of on the contrary, it kept some memories from her childhood. And while she was walking, she saw this lawn, which had this really interesting small cave. And Alice is not the kind of person that doesn't want to investigate something. She's quite curious, so she decided to see what's inside of this cave. And there she found this old workstation, which was working in some way, somehow, and a safe lock, kind of this small box, which rang a bell for her, but she didn't remember exactly where she's seen it. So on the workstation, she could see this open terminal reading cave Kubernetes, and Alice knew quite a lot already about Kubernetes, which made her curious what kind of objects exist in this cluster and how this workstation was even connected somewhere and would be able to have a Kubernetes cluster. So she just curiously decided to input kubectl get all, which allows just to get all of the objects that exist in Kubernetes system here or namespace. And what she got was persistent volume magic database with the age, which exactly coincided with the last time she visited this place. And that's where she got like her memories flooding back in, remembering that she had this adventure and that she took this magic database persistent volume with her. Just to make sure, she decided to input kubectl describe persistent volume and the name of the volume to get more information about it. And she got back like the name, the namespace, storage class, all of the general specifics, and somehow this persistent volume was still in the running state, although like 2 years passed at that point. So while Alice was researching, she just heard this voice from her back saying "long time no see," which obviously got her scared at that point. But then she realized that actually it was the pod that she took with her, and she was really happy to see him. But at the same time, she was kind of embarrassed that 2 years passed and she didn't really know what happened to him and kind of forgot about it. And the pod was really happy to see Alice too. And also he was secretly hoping that Alice would be able to help him come back home, or at least find a way to connect to his family back home, because he was trying to like connect with them and he was constantly failing at that. So he told her that over this time, he was just here in the forest in this cave. On the day that they played the last time, he escaped to the forest just to see what's outside of that house, kind of got bored, and he just got lost there and eventually found this cave and decided to stay there because it felt safe. And he had this safe lock with him. And also he found on some of the days this workstation, which he plugged into the safe lock, but it didn't really work in any other way. So Alice was wondering how exactly she could help him now. Although she had this knowledge of Kubernetes, she knew how it worked in his world. She knew Scala, but she didn't really know how to connect all of the dots. And the pod just said that actually she could use her knowledge of Scala because she could program some, like do the programming and actually create some Kubernetes objects for him. So Alice decided to accept this challenge and just research what's there, like how many libraries exist there that she could use for this purpose, what else she could do with that. So she just went into this research mode, And first thing that she decided to create was something very simple like the pod. Here's the definition of the pod that she wanted to create in YAML format. Just understand and compare how it's going to look in the Scala code from different libraries' points of views. So here we have the kind of the object, which is pod, the metadata part, the name of the pod, labels, specification part with the container definition, like the name, the image version, everything. So Alice learned that there are these three libraries, the more kind of famous ones that exist for connecting Scala to Kubernetes, and specifically two of them were used for Java. So you kind of had to trick something to make them work from Scala. So she decided to look into Java Kubernetes client, but the source code was actually auto-generated, so the functionality was not really wide, so she couldn't do much with that. And at the same time, it was very Java-like heavy code, which was not very fun to work with. So Alice decided just to skip this library if it's so hard to even create something simple from this library. She decided to go with another option, which was Fabricate.io. And here the definition looked like this. So she had to specify this pod builder and define all of the parts of the YAML file, very similar to YAML file here. The metadata part we can see here with new as the beginning of metadata part and end, which is like marking the end of that. The name, the labels, all of the same, and the container definition, and here with this add new and end work as kind of formatting way to specify different parts of the YAML file. So it's kind of mapped very well to the pod structure in the YAML file and look pretty readable, but at the same time, quite a lot of code to create something simple as the pod. And in order to actually create the pod, she had to instantiate the default Kubernetes client and make a call to the pods object on the client and create the pod in specific namespace. So again, it's quite simple, but at the same time, it's very, again, Java-like because you have to call lots of methods, lots of boilerplate code. And another option that she researched was SKuber, which is a small Scala library for Kubernetes. It's not like very popular, not that many people heard about it, but someone created this library and not very big amount of people use it, probably because not that many people in Scala actually code for Kubernetes. But it looked promising because she didn't need to work with Java examples. The source code was also in Scala, so she could just fully switch to her usual language. So in order to create the pod in SKuber, it's also necessary to instantiate the client, but it looks a bit different with this method init and providing the configuration. The next part is actually creating container. So here we can see the code definitely looks a bit different than Fabricate.io code. Then the label specification, the template is a part of spec in YAML file where we just define the container. And then we can instantiate the pod by calling create method, providing the pod instance, the name of the pod that going to exist in the system, and the template. So Alice definitely liked this one much more than the previous example, and she decided to go with that and just check what happens if she runs this code by just running kubectl get all to see how many objects exist now. And nothing happened because actually Alice was really impatient and she forgot after some time that working with Kubernetes means sometimes you have to wait for some, I don't know, minutes, seconds, depends on the object complexity. And she just needed to wait a few more seconds. So she decided just to rerun it before actually going into debugging mode. And indeed, it worked. The container magic link pod got created. And now this MagicDB cluster kind of had a new friend. So magic link pod was called in such a way to define this kind of link to the magic world that she was going to build. So important part here is that pods in the data model of this library on the part of the object kinds. So Alice now operated only with pods. Also, she had to work already with object resource type in the data model because it's kind of embedded into the object kind. Each pod has specification. Therefore, here we can see that object kind pod has object resource pod spec. Same with replication controller. Replication controllers have statuses in Kubernetes world. And here in this AskKuber API, they are defined as object resource of the object kind. Another kind that Alice didn't really use yet is list kinds. And these list kinds are useful if you want to actually list some kind of objects in the namespace or by labels. So their type usually looks like this, with list resource and pod or node or anything else you want to list. So the data model in general is quite simple, and it maps very well to Kubernetes API, where we again have some simple objects. We list sometimes objects, and we might have kind of parts of these objects like spec or status. So Alice thought that AskKuber is good enough for her purposes. Again, she wouldn't have to go with Java examples. She wouldn't have to rewrite some code, and she wouldn't definitely suffer with researching the source code because she would just have to read a bit of Scala code, which was fine by her. But at the same time, the pod was just like a training example. It definitely wouldn't help her to solve this issue. So she decided that for now, she just doesn't need this pod, and she called delete on this pod with the name magic link pod. So Alice deleted this pod, and now she could start from scratch. And she was thinking that she definitely needs more than just some simple Kubernetes objects, but what exactly would she need? And while she was thinking, she just got this great idea that they need more pods, which was a bit confusing for MagicDB cluster 0 pod, because like how the amount of pods could actually solve this issue. But what Alice actually meant was not the amount of pods, but more complex things, something that would be able to scale, and therefore she would have more pods than just one. So Alice decided to go with deployment object, and the definition is quite similar to the pod because it's just going to be called magic link with a container, same image, same labels, everything reused from the pod. But a bit different part is here. So it's needed to expose the port internal for the container, which would be 80. And that would be useful for building a link. And there is a deployment instantiation by defining that we want to create deployment with this name, with this template, we're using already defined template, and with this number of replicas. It's going to be 3 replicas. And replicas in this context means 3 pods because they are kind of lower in the hierarchy to the deployment. So when we create deployment, we automatically get pods and we get replica sets. So it's the same call to the create method on the Kubernetes client with providing the deployment. And aside from that, Alice decided to work a bit on some error handling. So she decided to call this recover with method and research a possible situation when she will run this code multiple times and deployment object would already exist at that point. So she decided to have this code to solve the situation. So in this case, she would just retrieve the deployment name and then print that she retrieved that, and now she could update it with the most current version using this metadata resource version. So it's quite simple code just for this error handling situation, but it's not super necessary. And here is a new method on the Kubernetes client called update, which is kind of similar the way we call the create and the new deployment with updated version is provided to this method to update this definition. So she got this deployment running, replica set running, and 3 pods now, like 3 instantiations, 3 replicas for this deployment, which was quite simple. So Alice decided that why not try to scale and see what this library is capable of, because usually she would be able just to edit the YAML file, specify the number of pods, and just go with it and get more pods. So she reused this method called getScale, which just retrieves the current scale of the deployment in this case, because we provide the name, we provide the type of the object, and then she would specify that she needs 6 replicas or 6 pods using this method with spec replicas. And she would update the scale of deployment by, again, calling it with a name and providing the actual scale, the desired scale. That's where this declarative nature of Kubernetes kicks in. And we can see that now Alice has 6 pods. But if you would pay attention to the age, you would notice that the age of all of the pods differs a bit. And specifically, first 3 pods are older than the last ones because they were not recreated in this case. So declarative nature works in such a way that we provide that our desired number of pods is 6. We didn't change the name, any signature for container, any specifications. So Kubernetes can just schedule 3 more pods and leave the previous ones. And we would have 6 pods without the need to recreate anything. So Alice thought that just switching from the code to this kubectl is not really convenient. So she decided to create her own method called listPods. And this method would output similar information, the one she gets with kubectl get all. So she just wrote there the pod, the namespace, and the status. And that's how it's going to be retrieved. So she would get from the list of pods in namespace, each pod retrieve its name, its namespace, and its status phase, which would coincide with the actual status of this pod, like what's happening to it. Is it running? Is it failing somehow? Is it container created state? So all of the statuses we usually see with kubectl get all. And in order to run this method, she would first of all provide the list of the pods in the namespace to go like one by one. And it works very well in this case, but usually we might have more pods which would be for different, which would belong to different deployments, and that would be confusing. And in such a way, we would have to differentiate them somehow, possibly by labels. In this case, we can just call list in namespace, the pods list, default namespace, we get the future, and we can map on each pod and call these list pods. And that's what she got as a result. Here is the name of the pod, the namespace, and most important is the status, because it's useful for debugging purposes. If something fails, you could just get into the pod, see the logs, and see what happens next. So now she got the most important information, and she could see that actually she could build something more complex in terms of pipelines, because she could not only create objects, update objects, create some kind of error handling around them, but also output some kind of debugging, just in general result, maybe put a watch on it to check constantly the statuses of the pods. But that was not the end. Alice decided to create a service. A service in Kubernetes works in such a way that it kind of allows each object where it's attached to communicate with objects in the namespace or outside world, depends on the type of service. Here, the service would be called magic service. The labels actually are reused from the deployment, which is not accidental. In this case, we tie this service to the deployment that we want to have we want these deployment to communicate with outside world using this service. So they're kind of tightly connected. And we have this 80 port because we exposed it from the internal deployment container, and the kind of client-facing port would be this 30,001. So it's going to be external port, which would be visible from the outside, and 80 is internal port for the container. So this expose on node port is called here, and the service is created. So we can see that the type of service is node port. There is a port and the age, only the visible port here. And we can have multiple of them. So it works like an anchor because it allows to, again, build this connection to somewhere else. So Alice thought that it's still not enough because in this case, even if she builds this connection to this world of the pod, she wouldn't be able to actually bring the pod back home. And that was her main intention. So while she was thinking what else she could do, the pod just entered into the service and ran this hello, hoping that someone would reply. And indeed, someone from that side of the connection replied, "Who's that?" The pod just wrote his name, hoping that he will get connected to someone. And as a result, he got this question like, is that really him? And that they lost him. And probably it was just someone from his world that knew that this pod got disappeared. So the pod was really happy because it definitely worked. And he could kind of have this chat with his home. Maybe he could connect to his family and at least have this kind of connection and not be like totally alone. While Alice was thinking how she could actually solve this task, and she just got into this problem-solving mode when, although you have some kind of results on the stage, on one of the stages, you actually want to achieve the final one, like the most desired result. So she knew that it was good enough, but there should be another way to achieve like the ultimate goal. While the pod was asking what exactly she means, like how could there be anything else to do that? So Alice was really kind of giving up already because she didn't really know what else she could do. She learned a bit about Kubernetes usage in Scala already. She learned how to create objects, but that was kind of fairly simple. It's not helpful in the situation of the pod. But pod was really supportive, and he just said that Alice could build anything she wanted. She already proved that by creating this magic database, by creating multiple objects in his world and creating them in this world using Scala for Kubernetes. So she definitely could build something that could possibly let him fly back home or move there in some way. And I always thought that it was a genius idea because that's exactly what she was going to build for him, something that would let him fly back home. So Alice reminded herself that Kubernetes has an API of objects, like the pods, deployments, replica sets, definitely not all of the objects in Kubernetes API here, but probably the most used ones. And as any API, it can be extended. So there is this custom object definition. And she actually built the magic database using custom objects. So she could build something customizable, something that would be like closer to her needs, and she wouldn't be like tied up using specifics of each object, whether it's pod or deployment. So she decided to research a bit in the source code of the library and see how custom resource is implemented there. Custom resource kind of is more like an abstract way to present custom objects, while an object is like an instance of that. So custom resource in source code looks like this. Its structure very similar to the one we've seen already for deployment or pod. So general structure has the same kind, API version, metadata part, specification, and status. So each object in Kubernetes has a status, the one that's displayed there, like running, failing, anything else. And also it has similar, again, structure with definition of these methods. I didn't provide the actual implementation here because it's not very important how it's implemented, just to understand what kind of structure the custom resource has. So it has the name, generated name, the namespace, labels, and all the other parts, which also similar for usual objects. But we also can have some custom fields. And also there is this status, and it's important to pay attention that many more simple definitions as they work for basic objects shouldn't be defined in such a way as they should be defined for custom resource because it's a custom type. So for example, here, a status which should be retrieved as running, again, failing, anything else. In order to have the status, we should enable it. Therefore, there is this status method enabler method there, or function, and it has this resource definition as implicit resource, and we actually enable the status, provide the message that it should be defined, and we retrieve it from the specification sub-resources part because that's where it exists. It's very important because some objects, some custom resources might have some custom statuses. Also, it's important because we want to build sometimes pipelines on top of them, and there can be tied up very tightly to the statuses that we want to have. For example, we want to run something while our object is running, which kind of obvious, but also if it's failing, we wouldn't want to run our application, or we would want to know what happened to this application. So Alice found this fascinating, that it's kind of so close to the way defined in Kubernetes, nothing extra and not that hard to understand, and seems like this functionality should work very well in this library. And actually, the creation of custom resource definition is very simple using this library. You just have to provide the name, the kind of the object, its custom kind, therefore it has a custom name. In most of the cases, we're already seeing like plot being the kind or deployment, and here is the custom kind called launcher. The scope would be cluster, and she created this CRD by calling save CRD method. Let's see what's inside the save CRD method. In save CRD method, this typical call to the create method on the client, but also a bit of error handling again. So Alice considered here a few cases. First of all is that some error happened and she wouldn't be able to actually create this CRD. So she just throwing this not found error and seeing if something goes wrong, and she wouldn't be able to create this CRD and have this Kubernetes exception in this case. Another Kubernetes exception would be similar case as with the deployment. If we rerun the same code multiple times, either in pipeline or manually, sometimes we forget to delete objects. So she would have to just update it with the current version. In this case, she would provide, again, the resource version from the metadata, current version for all the parts, like meta part, actually update this object by copying this metadata, and then calling this already familiar update object. So very similar technique here, just by updating all of the versions and getting like the most current one here. So it worked, and this launcher CRD got into the running state, and basically the launcher in this case is a rocket. So this rocket would be able to actually fly the pod back home because it's a custom object, a custom rocket, which was created for this purpose. So Alice was really happy that she succeeded in this complex task. She was able to learn like that quick and research that quick how to solve such an issue, which is again quite a complex one. And although the pod spent this time quite lonely and he was missing home a lot, he was still very happy that he was able to spend this time in this world, just explore it a bit, and possibly he wouldn't have these kind of adventures if he wouldn't just got lost here. So he definitely knew that it was kind of unique experience, and Alice was very happy that she was able to help. So they got inside in the cave. They didn't even get to the forest outside because the rocket was quite small. And then the pod just disappeared back to his home. And Alice was hoping that she definitely didn't mix up the port somehow, because that would be a shame. So now Alice knew that her knowledge of Scala could be very helpful. She built already simple objects like pods, deployment. She built them using kubectl, YAML files. She built them using Scala in this adventure. And she learned that there can be multiple libraries for these cases. So it's definitely an extensive possibilities that we could have by researching different libraries, choosing which one works best in our case. And Alice found this SKuber library quite useful and more Scala-like in terms of source code and all of the examples, and just in general easy to use. So now Alice knew that she could definitely build this link between her knowledge of Scala and Kubernetes. And more importantly, she could build just anything she wanted, just as the pod said. And it's a great start for possibly new adventures in the future. So thank you for attention. Here's my Twitter, GitHub, LinkedIn, speaker deck. So you can connect to me and ask questions about Scala and Kubernetes, or just Kubernetes in general. And I'll post my slides on my speaker deck soon and in Twitter. Thank you again. We'll be happy to hear your questions.
Hi, thanks so much for your talk. We all enjoyed it quite a bit. We do have time for 2 live Q&A questions, if you don't mind. The first is, how many functionalities of the Kubernetes API are covered by Scoober? Is there any advanced functionality not supported by the library?
That's a great question. Thank you. As far as I researched, the main functionalities that are covered are basic objects that I showed, like pods deployments. You can also research volumes, jobs, daemon sets, all of that. There is custom resources, which is very a nice one. But what I didn't notice, if it's possible to create something more complex like operators, and I'm definitely going to research that, but I didn't really see that in the source code. And also I think it's a great place to contribute for someone who's interested to do that.
Thank you. The next question is, may you answer what is the difference between libraries you mentioned and Nelson library?
Actually, I didn't really hear much about the Nelson library. I need to check that out. But in terms of differences between the libraries I mentioned, for some reason, the Java Kubernetes client is official Java and Scala client on the website, and I think it's still like that. But it's not very great library, as I mentioned, in terms of practical usage. Also, Fabricate.io has more users, both from Scala and Java, but it's also more Java-like. So therefore, research this SKuber, which is more Scala-like, but I will research Nelson and report back with my tweets possibly.
Well, thanks. Again, that is all the questions we have time for live. Thank you so much for being here and sharing your talk with us today.
Thank you. See you.
Thank you so much.